So just as a reminder, we'll be covering chapter 22 Arrow today. It's not a especially long chapter, but I found it to be an interesting chapter. But DJ is going to lead us today. We'll follow kind of the same pattern that we have for the past couple ones, talk about, open it up for any discussion about topics that people want to dig into more or any challenging topics. And then we'll cover I think, 3 exercises for today. So I'm going to turn it over to you, DJ, and then we'll go from there.
Yeah, awesome. Yeah. So we are trying to can I start share my screen just a minute? Just tell me what column.
No, you're fine. Take your time.
So yeah, we are trying to talk about today's chapter is Arrow. So can you see my screen?
Yep. I can see your desktop.
Oh no. Using my personal laptop today, so that's why.
No, you're fine.
Yeah. Can you see my screen right now?
Yes. Yep, I can see it. Good to go.
Yeah.
And you might want to bump up the text just a little bit. If you hit Command plus, it should bump it up for you. Yep, there you go. Yeah, it looks way better for me.
Yeah.
Looks great.
So yeah, so we are trying to discuss about the chapter called Arrows. Basically, Arrows is a multi-language toolbox which is designed to work on the larger data sets, which is like more than CSV files. We have like a multiple CSV files as consist like more than big data. So we use Parquet for efficient analysis and transporting the data for the large data sets. So Arrow package, which provides a deep layer backend and allows you to analyze the larger data sets by just giving not completely analyzing the large data set, but just giving like a proper structure of giving a sample of data which represent the whole data of that particular big larger data sets. So we use that Arrow package, and it works mainly with the deep layer backend, allowing you to analyze the larger data sets with the similar functions you use in the deep layer. And apart from that, yeah, we use like a tidyverse for that, and we install Arrow package and Arrow and yeah, and we use packet files. Basically, like packet files are like a column-oriented data format, which stores like the data in the columnary data format, and designed for efficient data storage and retrieval. And it provides a high performance compressions, like just compressing the whole bulk of data into a binary code kind of format, which it's not readable. Whereas we can see the CSV file, we can read like a humanly read format, but this packet files are very compressed into small format, which can be only processed with a particular function. We can see it. And packet files are like a columnar storage, which I mentioned earlier, and it's very good for performance. And Arrow package helps to analyze the larger data set in a very faster manner. So we can see the examples here. Like I just install packages, and DuckDB is storage space. I recently discovered it and I found very nice, and I'm using it for my personal project right now. And DuckDB is it's a columnar storage database, which is like a serverless. We don't need to install any servers, and it's very quick and it's very fast. So we use like a store that like all the packet files in that DuckDB right now, like for the examples. So yeah, and how to we are for this example we are taking a Seattle library checkout CSV file, which has like a more than I think it's 9 GB data set, which consists of 41 million rows. Yeah, 41 million rows, and which is from 2005 to 2022 data set, which is very large. And so we are downloading this data with using the function called multi-download, which downloads all the files concurrently, consecutively, instead of like downloading the larger data set, just gives us like a structure of the data set. Like if you see, and the directory create function helps us to show the data. And this function downloads all the data set. And right now we'll open the data set of the Seattle CV using an open data set. Generally we can use read CSV file, but the read CSV file has like a cannot handle that kind of large data set. So we use a open data set, which is a package, arrows package, where like we need to mention the source, and the ISBN is like we are dealing with books, right? So the unique identity of each book will be like a unique string. So we are just mentioning that column type to download the exact number of the what do you say, to know the structure of that data set for the to make the data set easily accessible. And the format is like a CSV. When you use the open dataset function, it creates like a Seattle CSV file. And when you type like Seattle CSV, we can get a like a proper structure of the what is the columns and their data types. And you can see here there are like a 12 columns, like a usage class, checkout type, material type, and title, ISBN. Where ISBN is like a primary key, I feel like in of this data set, like which have like unique values for each book. And these are like columns of the data set, which gives only the, like a proper structure, like without giving like all the data set for the larger data set. And you can see the like a glimpse function to see like a structure of that database, like a file. So we have like a 41 million rows, 12 columns, and data types, and the sample data. And this is the that. And if we see like exercise number 1, so the question is figure out from like a most popular book each year. So just taking like a Seattle CSV and piping to DuckDB. So basically we are like using DuckDB converts the data set Seattle CSV to DuckDB table, which is good for like faster analysis. And we are filtering like material type equal to book and title not equal to so we are just excluding the unknown titles from the books to get proper titles. And we are grouping by checkout year and title, and summarizing the total checkout is equals to sum of checkout, and removing the NA values, and grouping by drop last, where dot group last is ensures that after summarization the last grouping variable like title remains while remaining the deeper groupings. So this one here. And the slice max function used to count the number of checkouts. And collect function basically is like collect the final result back into our data frame from DuckDB. So this gives us like total like a most number of popular books of each year. And you can see here in the 2010 we have like the help and the Catherine socket, and how many books were checked out is like 2300. So something like that. So this is like a short glimpse of the most popular books for each year from 25 to 2022. And yeah, does anyone have any questions in the exercise number 1? Yeah, I can put the code here. Yeah.
Well,
Well,
I think
slice
just
max
go
actually
ahead.
works. I thought slice max doesn't work. When I looked at the description, it said it doesn't work on groups. Yeah, because you do a group by, you don't. Oh no, you drop the last, so the checkout year. Yeah. So if you look question mark arrow or whatever it is, a zero, so ACERO, when you get all the different. Let me just put it here.
Yeah.
When you run that command, then you get the functions available in arrow deployer queries. And then if you go down to slice max, it specifically says slicing within groups is not supported.
Interesting.
So can you show me your output if that's similar to what I have? If you go down, what data frame is returned?
Yeah.
The names of the
checkout year and the titles.
Yeah. Oh, that looks very similar to what I got. You have a few things you need to filter. See that uncatalogued folder or bag. That must be just something where someone doesn't know what it is. I don't know what it exactly means. And then video recording, obviously, is not a book. That must be wrong.
Yeah, it's a yeah.
But the slice max seems to work. Okay, this is very similar to the output I got. I didn't have time to really complete it, but because 2010, let's see, I have the help. Yeah. Oh, okay. Weird.
And I've just removed like all the values, unknown titles, just unknown titles. So maybe why it's not like remove this maybe video recordings or something like that.
Yeah.
I'm trying to figure out where you see the not supported for slice max.
Like DJ, if you don't mind, go enter that command that I put in the chat, the !acero. If you or I can't spell it to you. If you go into your console and just do !a.
So click on the little 2 window thing on the bottom next to the console. Yep. There you go.
Question mark.
Okay, yeah.
And then ACERO.
ACR?
E. No, E. RO. There, the first selection there. Yeah. And then in the help documentation, if you go down and then look for slice max.
Interesting.
Slice max. Yeah. Yeah.
And then it said slicing within groups not supported, is what it says.
What is only the NO?
So I didn't even try. I should have tried, but I was like, I'm reading the documentation and I'm not going to do slice max. And then it was like,
that's a good point. Huh.
But it seems to give a very similar result for whatever reason. So I'm kind of curious why. Maybe it arranges within the groups. Have you arranged anything?
No, actually.
No, you did not. And it should usually summarize, doesn't arrange by whatever your summary function is, right? Yeah.
Filter material. And I'm just looking at mine here, total checkout. Drop, slice max. Because I use slice max and I didn't know that that was not supported. That is important because, and you said that was ace row is the documentation. Huh, that's crazy because, what is this? Because I'm looking at like just the dplyr slice max.
Yeah.
And like if you just do question mark and you look at slice max, it says something about arrow, but it doesn't it's not really clear about like what it is. Like it has like arrow, dplyr query, arrow tabular. What am I looking at? Methods available and currently loaded packages. So I don't know if it's now supported and the documentation just hasn't been caught up, but that is a really important distinction. Like if you go down to like the methods portion.
Yeah, I see it.
But that's not really clear to me
what that means.
Which means that packages can provide implementation methods for other classes. For extra arguments and differences in behavior. So slice max, arrow dplyr. Huh.
Yeah, maybe they did not update the documentation. I mean, we can just do like some spots. So what I did, like basically, I just mutated and created search for the max count and then filtered for the max count, and that would return me only a single row. So that worked, but I think the result is very similar. So I mean, if you can you add to your command and arrange by arrange by the year, so that we have the checkout year, that it's arranged by that, and then just, I don't know how long it will take for you to run the command. My computer was slow. It was a checkout year.
Cap, yep, checkout year, yep. And pipe.
It'll take a little time.
Mine was pretty quick. I mean, piping it to DuckDB was pretty quick for me, but well, no, you guys are using the Seattle CSV. I just went with the Seattle PK or the Parquet.
Oh yeah,
So-
but no, I'm doing that too. For me, it was taking that long.
Oh, that's crazy.
Okay, and now, like if you go, so the first ones are these uncatalogued folder, okay. And I definitely also have Margot at the wedding. I
Yeah.
have the help next. Yeah, that's the same. The Hunger Games. Yeah, okay. I mean, that would be really a big coincidence that, yeah, the Goldfinch, Girl on the Train comes after that. Okay, it looks very similar to my output, except that you didn't fold it for the uncatalogued folder or bag. So it seems to kind of work because why would it give such a good result? A similar result. Okay, anyway, so I don't know, maybe that doesn't matter anymore. But I was surprised that it worked. Oh no, it doesn't. Maybe it works for you because you're working with a CSV file and not a Parquet file.
Yeah,
Would that
I'm
be?
Let's see. Let me
And then it's
see.
dbplyr. Yeah,
Yeah,
then it uses dbplyr in the background and not a Sero, which would be the arrow implementation. And that's why your slice max works, would be my guess. But you, Colin, you said you get a similar result?
Yeah, but I didn't filter out for the unknown titles, but I just changed it. So DJ, can you show me the table that gets returned? Can you show
Yeah.
me the, because I got to make sure it matches up. So I have it looks exactly the same because I'm getting the 3 on catalog folder or bag, then Margot at the wedding, the help, the Hunger Games, Where'd You Go, Bernadette. It looks exactly the same. And I did the Parquet file. Like I took the Seattle PQ, piped it to DuckDB, and then just did all the filtering. So I think it, at least with this example, it seems like it's doing the same thing. Maybe it's just the arrow file hasn't updated, or the docs for the arrow.
Maybe. Yeah. Could
Because
very
I
well
know
be.
arrow is completely separate from posit. They're complete. I think if I remember correctly, they're they're supported by, who supports them? I think they're supported by Apache. I can't remember. I'm not
Yeah,
sure.
Apache Arrow. Yes, totally.
So maybe the posit team was like, listen, like this is going to be a supported, like people are going to use this arrow package, which I know is really popular, especially if you're dealing with big data workloads. So they're probably like, we should have a method for slice max if it receives like an arrow tabular or arrow dplyr like item. Huh.
Oh, this is interesting. Like I just had slice max and I tried to run it and it says slicing group data not supported in arrow. I get that. Oh, but you changed it to DuckDB, right? Did you have two DuckDB?
Yeah.
Then you're not using arrow. So that's the difference. Okay. You're using dbplyr in the background and it automatically knows which one to use. So okay.
That's what got confusing to me too, like understanding like what technology we were actually using. Like, so we start with the file type, which was Parquet. Go ahead.
No, no, please. I think you're gonna express the exact same thing. That was one of my questions. So please go ahead.
Yeah, so like, okay, so, and I should have read the arrow package a little bit more. Arrow just is a tool to translate your data into a specific file type, right? Or like it gives you access to the C library or C++ library to translate into different data formats. DuckDB is the database backend that you can pipe it to use it, right? To use like the database access to it. And then dplyr has a translation to DuckDB objects to perform dplyr verbs, is the way I understand it.
Yeah.
Okay.
Yeah. And I didn't look carefully at the methods. I didn't think about methods. I was like, how does it work that R knows when there's a slice max, which version of slice max to use? Is it using the dplyr or dbplyr? But it really depends on the object, right? So it knows the object and then uses a method for that fits that object. Yeah, I was also unclear, like, but that's also my understanding. Now it's actually running DuckDB in the background, and I was like, why would I run DuckDB in the background if it can load the Arrow already helps you to do stuff from disk, right? So why do I need to run DuckDB? I'm unclear if there's any speed benefits. When I tested it a little bit with one of the other examples in the book, I did it with DuckDB and without DuckDB. It was slower with DuckDB in my case, like not by much. I forgot the numbers, but it seemed slower on average. Like I didn't do it strictly quantitatively, but it seemed a little bit slower. So I don't know what that means.
Yeah, I was kind of playing around with it too, like just watching my, like I turned on I use the top command to watch
Oh
like
yeah,
the processing and stuff. And again, I didn't do any like hard numbers on it, but it's, if there was a performance boost, and I'm using a pretty fairly new MacBook, I mean, it was negligible. Like I wouldn't have known the difference. Like, but maybe if you're dealing with like more than, was this 14 million rows? Millions more, maybe you would see a difference, but like I didn't see any difference. But I could venture to guess that there's probably workloads out there that people are way above whatever this data size is. So, which in and of
okay.
itself is pretty amazing. I mean, like it's pretty amazing to see that this thing can, on just one computer, just a laptop, just crunch through 14 million rows worth of data, which is unreason. It's just crazy to me to think that they can actually do that in like half a second. So, but
Yeah.
all right, DJ, you want to talk
Okay.
about number two?
Yeah, that's for the exercise one, and the exercise two question is which author has most books in the Seattle library systems. So for that, I'm using like a filtering like material type equal to book, and the title is equal. So I'm removing just unknown titles and group by the creator column and summarizing the total book with a ISBN number, which is like uniquely assigned for each book, and arranging it by descending order and choosing the collect for converting the into art data frame, and the results is like this one. Yeah, yeah, that's simple. Yeah, do you have any questions on this thing?
I'm just looking at it here, just comparing mine to yours here. Creator. Oh, okay. I see what I did. Okay. Has the most books. Okay. I just grouped by, I did an additional group by, I added title. I shouldn't have done that. I should have left title out, but I did basically the same thing.
Yeah,
So I actually got a view of like, let me take away title and see if it matches up with yours, which I assume it would. Yep, it matches yours. Yep. I just added title. So I actually answered the question, which author and title has
okay.
the most, or which, I can't think of it. I can't think today, but like which author and title, or how many books were there for each author and title in the Seattle library system? So I answered that question, but that was just a simple mistake on my part by adding too much to the group by, but I have the exact same.
Yeah.
So I have now a question. I'm curious. If you add at the end of your command the pipe to system time and just run the command and see how long it takes. It's system time. That's that. No, that gives you the time, right? The local system time. It's system.time. It's lowercase system. Yeah, there it is. Yeah. If you run it, because I would expect that this is going to be slower, and if you change it to the PQ Seattle_PQ, it should be faster, right? Because it can access the CSV files faster, the Parquet files faster than the CSV. Okay, so this was 13 seconds.
Yeah.
Okay, and now just change the underscore CSV to PQ. That should still work, right?
No, I think so. I need to do it from the top.
Oh,
I
you
just
haven't.
ran it.
Okay.
I ran it on mine. Well, this is piping it from the PQ files, the partition PQ files to DuckDB, and it looked like it ran. Well, I'm seeing user 11, system 1.0, and elapsed 1.285. So I think it's a little bit faster, but again, difference in computers, because I think, like I said, I'm running on a newer MacBook, and I don't know what year your personal laptop is, DJ. So
if you change it to a CSV, do you have it loaded? Can you see what the difference is?
let me see if I can do it. So what is it, Seattle CSV?
Yeah. Because I thought that was the whole point of the chapter. Basically, you should not use the underscore CSV, right? Because it is able to use the arrow package to load CSV files from the disk. But if your data set is really big, it is worth partitioning it into Parquet files, and then your analysis should be much faster. Or did I miss?
I think you're on the nose, because just qualitatively I got a spinner.
Okay.
And then I got the numbers. Like if I just do like the PQ files to DuckDB into the pipeline, it's so snappy. But when I did the CSV, I literally got a spinner.
Okay, cool.
Sorry, I didn't mean to cut you off, but when I had that experience, I was like, if you see a spinner, it's definitely slower.
It's usually not a good sign. Okay, awesome.
Yeah. And the third exercise is like, how many has checkouts versus book versus ebook changed over the last 10 years? Basically, like filtering the material type, ebook and book and ebook, and group by material type and checkout year, and just summarizing it and adding a ggplot and just finding the trends, like comparing the ebooks versus books. And yeah, this is that. And yeah. The code.
I think I had the same answer. I just did a line chart instead.
Yeah.
Which, I mean, they're just basically comparing the same things, but
cool.
Yeah, like I said, I am just blown away by how much faster. I mean, there's like one data set that I have in mind that we do have that maybe touches a little bit of this, but in our day-to-day work, I don't see us working with this directly. But like that one data set that I'm thinking about right now, I'm like, because it's like a text-based file that we have, and it's over a few million rows, and it's getting bigger, and I can tell that if I just do a regular dplyr pipeline on it, it takes so long. Like every month that I have to run it, I sit there and I'm like, okay, well, I'm just gonna let it sit for 30 seconds or a minute, and then I'll come back, and then it'll finally be run. So I could see us using this for that, which is really interesting.
Yeah, it's pretty awesome.
Yeah.
And then the other thing, I was just digging into it too, like I wish this, and it does kind of show it a little bit, because I think at this point, like if you have such large files that you're working with, you're probably going to well, I guess gigs isn't too bad on a like a local machine, but if you're getting any larger than this, you're probably going to be working in cloud storage, like, using like GCP or AWS or something like that. So it was kind of nice to see a little bit of how you can actually use that in the chapter when we actually downloaded the data, which took quite a bit of time because it's such a large file. But I was reading a little bit more in the Arrow package where it has a really clear explanation about how you can use cloud storage with Arrow, which I was like, oh, this is phenomenal. Because I can tell from past experience, and maybe we're just using a different package, like anytime that we've interfaced with like cloud storage stuff, which is CSV files, it's always kind of the infrastructure behind it's not as great. And so maybe this is a little bit more supported or a little bit more stable than some of those packages that we use. So might be worth kind of exploring a little bit more. So hint, hint, wink, wink, DJ.
Sorry.
Yeah. And then I think there's just like a little bit of wisdom in here too. Like I thought there were some really good points, and I don't want to dominate the conversation, but I thought there were some good points about like how much, what was it, like the gigs to RAM, which I thought was interesting. Like you should always have double the amount of RAM that you have for like size of your data, which I thought was interesting. It's always nice to have those like little tidbits of knowledge because I don't deal with that stuff on a day-to-day basis, and it's just great to have those. And then I think the 80,000 rule was really important too, where Arrow is only going to look at the 80,000 rows. So it's probably good to be very explicit with your data types, because like 80,000 rows isn't very much, especially when you're talking about a big data workload. So it's very important to keep that in mind, but pretty cool. I like this chapter. It was short, to the point, and it seemed very useful. So
Yeah.
anything else? Anything else anybody wants to add?
Yeah, just I was like trying like with a format as a Parquet, and I'm checking the time of this process, but it's still showing like a 13.4 second. Maybe maybe with a laptop, I think so.
Do you still have CSV on the top? You have to change the PQ.
Okay.
No. Oh, you.
Yeah, I ran a new file. So let me change actually this thing. PQ. Let me run.
Do you have it partitioned?
No. Oh, sorry. You need to load it. So you wrote it, right? You wrote the data set to the.
Yeah.
The CSV was correct. Sorry. This part is you write the partitioned version to the hard drive, but then when you go down, you're still using Seattle underscore CSV, but you actually need to load now the Parquet version, right? This is still, you're just accessing the CSV files in your next code chunk. So you need, what was the command? I can
Open data set to the PQ path.
Yeah.
I can post it in the chat here if you need it.
Oh, thank you. Yeah.
So here's the chat. So that's that one, the open data set to your PQ path. So you need to do that after you. So right before your lines 84, you need to add like this line that I just copied and pasted.
Yeah.
Which while you're doing that, like the partitioning thing's really interesting. It's kind of like a view. I view it kind of as like a view in a database, right? Like it's just a way to speed it up, which I thought was interesting.
Like here,
makes you really think about your data organization though. Like how you organize your data, because it's not one file anymore. It's a directory of multiple directories with files in it.
Yeah, and then you have to anticipate what kind of queries you have often, right? That was the point that I find hard to think about. So like, how do you decide? Like, I feel like too inexperienced yet to make those kind of calls.
Yeah,
That's why it's kind of nice with the database, because then you could just use a view. You can use a view in a database, and you can specify that within a query. But this, you have to really think about like, okay, what are the yeah, like you said, you really have to think about like what column am I actually going to be using to filter on. So did it work,
Yeah,
DJ?
yeah, it worked, and it got into 7 seconds.
Instead of 13, right? It was
Yeah,
13 before. Yeah.
half.
Okay.
Yeah.
Man, that's just it's crazy to me. Because I mean, even just like, well, I know because we use Big R Query and just the like just the latency to actually pull data out. It's not the processing of data, it's the transfer over the network that takes such a long time. And that's because on the back end, I think it's using JSON files, which I think they wrote an update for that, so they're going to change it. And I actually think they're using Parquet now, but that's not in. I don't know if it's on Cran just yet. Don't quote me on that. I have to look at it. So it will make it faster, but like just thinking about this, doing it locally is just really just a neat idea. So
Yeah. What did I want to say? I'm surprised by no. Yeah. Anyway, I am trying to wrap my head around it and trying to decide when it's worth. I think one of the other consideration, if you have it actually properly in production, then you have all those additional dependencies, right? Is that why people are hesitant to adopt it?
oh, for Arrow,
Yeah, for Arrow, yeah.
that's a great question. I'm not sure, and I don't know if I'm the right person to answer that question. I don't know, DJ, do you have an opinion on that?
I don't know.
I noticed it's hard to compile whenever it's not on CRAN and you have to compile it yourself. Like you have to have so many dependencies. That seems always like very
Starting.
fraught.
That too. I think that's a big thing, but I also think another part of it too is like I would well, I shouldn't this is totally an assumption and I have no any data to back this up, but I would assume that a lot of people are dealing with like big data problems, not like not big data, but large data, not big data. Yeah, and I guess that's context specific because I'm sure there are people out there that deal with this on their day-to-day basis, but like in our role, like if you're just an analyst, like there are very few data sets that I would characterize as like big data that we work with. And so a lot of the stuff that we deal with is either large to small. And so I just wonder if like people are just like, hey, I have 1,000 row data set, 2,000 row data set. Do I really need the performance benefit? And then, like you said, that extra bump of like, not only that, I have to compile it and do all that stuff and have that extra overhead to adopt it. Because I think even with like, and I'm using our experience of using like big R query, like Hadley has made mention, I think in a presentation, he's like, it really amazes me these people who have these like really small data sets, but they're sticking it into big R query and using it. When is there a better way to do it? Why not just use a CSV? And at some points, I say that I'm like, yeah, that's true, but there's also another couple features that are nice with it as well. But yeah, there's just additional overhead that you have to have that if you have a 2,000, 5,000 row data set, do you really need to do that overhead? I don't know. It's fun though. It's certainly fun to throw a 9 gig data set at this and just have it crunch through it is really amazing to see.
So DJ, you mentioned you looked in a personal project at DuckDB. Is there anything like your takeaways, or at what point do you feel it's worth using DuckDB? That was
Ye-
also something I was curious about before. Like my data set is not that big. I think it's a few million lines. And I was like, oh, should you? And so I have some pipelines when I run them in dplyr, the data is a tibble and it takes like, I don't know, a minute to run it. So similar what you mentioned earlier, Colin.
Yeah.
And I was wondering if I should implement it in DuckDB, because if it's snappier, it makes it so much easier, right? When you iterate, you don't have to wait long times. But I didn't know, like, if I was basically didn't have a rule of thumb to follow if it's worth the effort. And then the other consideration was kind of, it seems like very popular right now, DuckDB. So I felt also it might be like a technology to know about, and being like versed in it is beneficial. So that was my other thinking there.
Yeah. So yeah, I feel like why I'm using DuckDB is like basically it's like a serverless, and when you compare with like a cloud storage, and it's open source. And actually I'm using it for one of the app I'm right now like working on, like it's a personal, but it's like a ride sharing app where I want to build, like I want to use that so I can learn it, and I can like work on the ride sharing app instead of using a PostgreSQL. I was planned to use PostgreSQL, but I was like, okay, let's do this DuckDB so I can learn it and I can see like the basic. I feel like it was very fast, and it's a columnary storage. When you even the bigger query, BigQuery also use a columnary storage, something like that. So that's the reason I'm started like I want to learn it and I can use it like in my app instead of like a PostgreSQL. So that's the only reason, and I just use it, and yeah, that's it.
And why not SQLite instead? What is the advantage to use DuckDB versus SQLite? Because they are pretty similar, right? Because they're both in process. They're like the most comparable in like.
Yeah, and one more reason is like an integration with the Python. So I'm using Python for my backend scripting. So where like DuckDB has like a, what do you say, like a ease on like using pandas and everything, like when you with the Python when you're scripting in Python. So that's one of the other reasons. And SQLite also I used previously for one of the project called a web scraping project in Python. So I used SQLite for that, but I don't know, like it's a I found like after going through DuckDB, and I feel like okay, maybe it's easy, so I'll try to work on this. So that's I just want to learn, so I just using it my project so I can learning DuckDB more. Yeah.
Yeah. To make sure, I was just curious if in your learning you know have already like figured out some things where you're like, oh, I wouldn't use it in this context, but exactly. But thank you. Yeah, that's awesome.
I think also too, I think that like that presentation that I shared from Posit last year did a really good job of pitching like good use cases for it. And I was blown away by the one of the creators of DuckDB when he mentioned like he's like the idea of paying AWS, paying GCP to process your data. Now you don't need it. The idea of like needing large servers to process your data, which can be done on a single laptop, is just it's a game changer if you're willing to implement it. Um, there's a really good example that he shares in there that I was kind of like, okay, I could definitely see how this is a game changer if you're willing to adopt it. There's also some tooling with the tool that I thought was interesting. You could also treat it kind of like a package. So you could write like SQL functions, and DJ will know more about this because he's been digging into it, but you can kind of treat it like a package. You could write functions inside of it and wrap it all into one thing, one object that you can ship off. So it's not necessarily in its own environment. It's like an object that you can ship into many different places rather than it being just on like a server. So I thought that was kind of a neat idea because I could see like if you had data that you could version control, you could just put it in there, even though that sounds kind of like a mess. But like if you had a small project that you wanted to share to people, you could just have a DuckDB package and ship it off to whoever needs it. So
And that means it's like queries, standard queries that you would have in your pipeline, and you can give it, and then someone can just say, okay, oh yeah, that's very
then you
interesting.
just run the DuckDB function, and it's just all packaged inside of that DuckDB object, which I thought was kind of a neat use case.
Okay.
Yeah, so it's like you're translating your pipelines into SQL, and it's like a package, but for a serverless database, which is really cool.
Yeah. Actually, I recently made a post on in the LinkedIn also like about this DuckDB. So yeah, even after that, like I was seeing another database called Singlestone. Maybe it's developed by it's mostly used by banking system for a large data set for a transactional data. So it's very like they have like a OLTP and OLAP for both that Singlestone database. I didn't use it, but it's I think it's not open source. It's a private like company owns.
Okay.
Yeah. So yeah.
And what's interesting about DuckDB is the story behind it. So I think one of the original creators, and I unfortunately don't know his name, he was the one who gave that talk. He used to have a pet duck, or
Gabriel
still has a
Miller, I
pet
think.
duck. Yeah,
Yeah.
he has a pet duck, or used to have a pet duck, or has a pet duck, or something. And like that's why he called it Duck TV, is because of his pet duck. And actually, that's the symbol. So if you see the symbol, the circle, it's because it's a duck. But supposedly that was his pet or something. I don't know. It's interesting that somebody had a duck pet, but all right, cool. Well, I really appreciate everybody's conversation. This was a cool one. Yeah, I think we did a pretty good job today. So I'll give everybody 15 minutes back. So appreciate everybody's time, and we'll do next week. I think I could probably take it, but we'll go from there. So I'll see everybody next week.
I meant to say I'm not going to be there next week because I'm at a conference, just so you know, just as a heads up. Yeah.
Cool.
Okay.
Cool. If it's just
Awesome.
DJ and I and anybody else, we'll see everybody next week.
See ya.
Bye.
All right, see ya.